Myself V.V.Gopala Rao, Assistant Professor, Department of Computer Applications, Aditya University. Today I am going to deal some topic related to data link layer, in which prominently we are going to discuss about flow control and error control, which is a very important process we have to consider, because flow control and error control are very important for the sake of the data and its validity. Of course, before going to the actual concept of that, after completion of that, we are expecting that the student can be able to know about the introduction of what actually flow control is, and similarly the student can able to understand at least the basics of the meaning of error control, and also what is the meaning of noiseless channel and a noisy channel. And of course, we are now today discuss about what are the protocols available for noiseless channel to conduct the transaction of data communication properly with respect to data link layer. And okay, let us start with the actual flow control and error control, the definitions part. So let us discuss about the very fundamental concept called as flow control. Actually, what is the meaning of flow control? Why actually this is necessary? Flow control itself is saying that the actual flow of data transmission should be in a controlled manner. That is the actual meaning of the flow control. Some process should be there to control the flow, otherwise there may be some consequences because of the overloading of, because of improper transmission of data, and without any control of data transmission, so many problems may occur during the transmission. So that is why the flow control is a basic process by which the control can be focused on the flow of data. The data may be in the form of frames, or the data may be in the form of bits or whatever it is, but that should be controlled, otherwise you have to face the consequences. Then what are the steps we are going to take? We are going to introduce with respect to the control of flow can be referred as flow control techniques, because in this we have to follow certain procedures so that we can restrict the amount of data that the sender can send before waiting for an acknowledgement. Whenever we are talking on phones, this is a basic thing generally we follow. Whenever you are ringing to a friend, then you cannot talk without any response from the other side. So that is called as an acknowledgement. Once some fellow is responding that, then only you are going to actually start your conversation. So before that, whatever the steps you are following can be referred as establishment of connection. So similarly, the phase is to be controlled by following a procedure. So that is actually meant in the actual flow control concept. So the sender has to follow certain procedures. Based on that, the amount of data to be transmitted from the sender side is to be controlled. So based on that, so the data transmission will be continued, or the data transmission can be carried out in a successful way. So in this, what actually the main thing we have to consider is we have to see the acknowledgement part. So somebody from the other side, from the receiver side, should respond yes or no. So that is called as an acknowledgement here. So now before going to the other thing, let us consider that there is one more important aspect we have to be very careful, and that is called as error control, because flow control is meant for controlling of the data flow, but error control is meant for controlling the errors. That means whatever the frames we are sending from the sender to the receiver, so sometimes the actual data may be, or the frame may be lost, or sometimes the frame may reach to the destination after the time is expired. So these are the problems generally we may face whenever the transaction is taking place. So some process should be there to control or to look after all these things, and that process is referred as error control process. So here error control process is based on certain steps. That means sometimes you can transmit the frames again, or sometimes you can transmit the frames which are actually sent based on request. So that is why, so there is some kind of a process we have to follow with respect to the error control. So finally, the flow control and error control in the data link layer are very important to see the safety of the data and moreover the reliability of the data as far as the data transmission is concerned. Now, how to achieve this? So, there are certain protocols to control the flow basically. So, there are two types of channels actually classified. The one is called as the noiseless channel, other one is called as the noisy channel. Generally, data link layer is very close to the physical layer. Just below the data link layer we find the physical layer. In the physical layer you may find, or you generally see the medium that is responsible to allow the data to travel from the sender to the receiver. So, in this case of the data link layer, for the purpose of flow control, we are actually concentrating on two types of channels basically. One is called as noiseless channel and the other one is noisy channel. But for both these two different channels, different protocols are actually designated. So, we'll find out what actually the basic process in each and every protocol with respect to the flow control in the data link layer. Okay. So, in this let us discuss with what actually the meaning of noiseless channel. So, noiseless channel means a channel, a medium which will not give you any kind of problem when the transmission is taking place. That means will not give any problem in the sense you will not lose any data, or there is no, okay, say that there is no problem of using that channel. So, there is a guarantee that whatever the data you are transmitting, definitely it will reach to the destination without any problem. So, such a kind of channel or a medium can be referred as a noiseless channel. So, here in this case of noiseless channel, generally we won't lose any frame, or similarly no frame will be duplicated, similarly no frame will be corrupted, because the channel is very clear. So, that is why we are expecting that this channel can be referred as a noiseless channel. Okay, for the noiseless channel, as I have shown in the previous slide, there are certain protocols by which you can able to control the flow. So, in that the first protocol is referred as simplest protocol. Simplest means the name itself is saying that the process what we are following in this kind of protocol is very simple. So, here for all these kinds of processes basically you have to focus on sender and receiver, because the starting frame is from sender and it has to reach to the destination, that is called receiver. So, sender and receiver are playing a very important role for sending and receiving of the frames. So, but whatever it is in the simplest protocol, as I am showing that on the screen, you are finding sender A and the receiver B, and there are certain frames which are colored and which are represented as frame like that, and there is one word that is used that is called request, and on the other side you are finding that arrival. So, these and of course, there is a dotted line you are finding, and that is called the timeline. That means whenever the sender is sending the frame, so it has to be reached to the destination within time. Otherwise, so what will happen is the sender will be in a in an assumption that the frame is not reached. Okay, that we will see that how actually the procedure can be carried out. Let us start with the first one. That means here let us say the request is made by the A, whether receiver B is ready or not to receive the frames or not. Once the request is made and once the sender A is getting the proper response from B, then A can start sending its frame, and once the frame is put in the channel, because it is noiseless channel, so there is a definite there is a definite chance of sending the frame to the receiver without any problem. So, imagine that the frame is traveling in the medium and finally it is reached to the receiver and the receiver received it in a proper condition because no damage is expected, no corruption is expected, so that the frame is again in a proper shape will be received by the receiver here. Like that, all frames, once the first frame is reached to the destination, then automatically the second frame and followed by the sequence of frames will be put in the channel, and one by one, all the frames will be carried to the destination, and all frames will be again collected by the receiver, whatever the order that the sender actually sent in this channel. So that is why, because it is a noiseless channel, you need not check whether the frame is reached to the destination or not, because there is no traffic congestion, or there is no congestion that is going to take place in this, because only one frame, as far as the channel freeness is concerned, only one frame is actually there in the channel. So definitely it will go to the destination. So there is a guarantee that all frames finally reach to the destination. But this particular simplest protocol is very difficult to identify, because these noiseless channels are very rare to identify. Because you cannot find noiseless channels practically speaking. You have to provide dedicated lines, dedicated channels from the sender to the receiver, but as far as the expenditure is concerned, it is more and more expensive. So generally we won't prefer for this kind of noiseless channels, because it is very expensive, and it is, practically speaking, it is very difficult to manage like this. So here the time that is timeline that is showing is it is only to identify what actually the time that is taken up by the frame to travel from sender to the receiver, and you can estimate the total time that is required to complete the overall the transaction of the data. Okay, so that is about the simplest protocol. Then coming to the other protocol, if you see in this noiseless channel, there is one more protocol that is called stop and wait protocol. So here if you see the figure, so there is a slight difference between the earlier one, simplest protocol, and this one. So here the frames are transmitted, but there is one portion that we are finding that an ACK, that means it is a frame which we are expecting as a sender from the receiver. ACK means acknowledgement. We are expecting an acknowledgement for every frame from the receiver to the sender. So that is the added step that is actually identified in the stop and wait protocol here. So first of all, the sender starts its request whether the receiver is ready or not for taking the frames. So once it got the proper acknowledgement, then it is going to start the frames sending. So let us imagine that the A is sending the first frame, and because it is received received by the receiver properly, because it is a noiseless channel, so there is a guarantee that the frame will be reaching to the destination, and immediately after received by the receiver will acknowledge that by sending a reverse frame, which is actually termed as ACK. Then ACK is traveling from B to A, and A is able to receive the acknowledgement frame. Once he notices that the ACK frame, then only he is able to start sending the second frame. So that means here why the stop and wait name is used here, because once the frame is sent, the actual A should stop for some time and wait for some time. Until what time the sender has to wait? The sender has to wait till acknowledgement is received by the sender. Once it is happened, then it is going to start sending the next frame, and again wait for the acknowledgement. Like that, the process will be continued till all the frames are over. So that is why this total protocol is going to actually going to follow on two important policies. One is called as sending and finding out the acknowledgement. Again sending, finding out the acknowledgement. So this is the way how the process is actually carried out. So that is why this process is called as stop and wait protocol. And that is about the noiseless channels. Now again actually I have shown that there is a noisy channel. So this is the controversial, or it is actually a complement of the actual noiseless channel. So noisy channel automatically tells you that there are certain problems you can find out with respect to the frames. The frames may be lost, or the frames may be duplicated, or the frames may be corrupted. So there is a quite chance of finding out in this channel when you are allowing the frames to travel in the channel. So that is why this channel, which is actually showing these problems, can be referred as a noisy channel. Generally we can go with noisy channel only because I already told you that noiseless channels are practically very difficult for you to establish. So that definitely we have to go for a noisy channel. So here also we have to be familiar about the protocols available. Even though we have certain problems like frames lost, frames duplicated, or frames corrupted, even then we have certain protocols by which you can able to control the flow. So that we can say that the important protocols or the available protocols for these noisy channels are classified as stop and wait ARQ. Here ARQ stands for automatic repeat request, and the second one is called as go back N ARQ. Here N stands for the number from which again the frames are to be retransmitted, and selective repeat ARQ. Here the repetition will be based on the selection that is made by the actual receiver. So these are the things protocols available for the noisy channels. So now in the next session we are going to discuss about the protocols one by one regarding to the noisy channel, and these are related to the flow control which are actually conducted by the data link layer. Of course, after completion of this, I hope that student is familiar about the fundamental definition of flow control, and what is error control, and what is meant by noisy channel, and what is meant by noise channel, and what are the protocols available for noiseless channel, how they actually conduct these steps. I hope you are clear about all these things. Okay, thank you.